I want to begin today with a really brief review of the rules of exponentiation. First of all, what do we have when we multiply powers with the same base? A to the x times a to the y. This is something that I think people often memorize. You know, when you multiply powers, you just add the exponents. But this is very intuitive also. If I give you something like 5 squared times 5 cubed, 5 squared is 5 times 5, and 5 cubed is 5 times 5 times 5. And if I multiply those all together, I have 1, 2, 3, 4, 5, 5. So 5 to the 2 plus 3, or 5 to the 5th. So this is one rule for exponentiation. When you multiply powers with the same base, you add the exponents. Second, if I divide powers, a to the x divided by a to the y is just a to the x minus y. This makes sense too. If I have something like 3 to the 5th divided by 3 squared, I have 3 times 3 times 3 times 3 times 3 on top and 3 times 3 on the bottom. And 2 of the 3's on the top cancel with 2 of the 3's on the bottom, leaving me with 3 to the 5 minus 2, or 3 cubed. So this should make intuitive sense also. Third, when you raise a power to another power, you know, when you raise a power to a power, you just multiply the exponents. And this should make all sorts of sense too. If I take 7 and square that and then cube it, this is 7 times 7 3 times 7 times 7 times 7 times 7, or 7 to the 2 times 3. So these should make sense. If I take anything and raise it to the power 0, that gives me 1. Again, if you believe number 2, you gotta believe this, because if I have something like a to the 0, I could write that as a to the, let's say, 2 minus 2. 2 minus 2 is 0. And this would be a squared on the top and a squared on the bottom. Anything divided by itself is certainly 1. So if you believe this, if you believe number 2, you have to believe number 4. And if I have something like x times y to the power a, this is just x to the a times y to the a. We know exponentiation distributes over multiplication. It also distributes over division. But I want to point out, exponentiation does not distribute over addition and subtraction. If I have a plus b squared, this is not equal to a squared plus b squared. You know what this is equal to. This is a plus b times a plus b. If we FOIL this all out, we end up with a squared plus ab plus another ab plus b squared. So exponentiation doesn't distribute over addition, and it doesn't distribute over subtraction. But that is one of the most common algebraic mistakes people make. Make sure it doesn't happen to you.